I'm Dottie Metcalf-Lindenberger. Currently, we are in the lab of the International Space Station, which is one of the original modules of the U.S. segment. It used to be the biggest, but now the GEM is the biggest module on the International Space Station, and we have a whole section up front that makes this quite a large facility. But this is where currently we're doing our robotics. The space station arm is much more versatile than the shuttle's robotic arm. It's longer, it has extra joints, and I'll talk more about those joints, and it also has the ability to move on the mobile base system back and forth on the truss, and to do what we call a walk-off, which is to go from one power data grapple fixture to another power data grapple fixture and basically act like a little inchworm. Grapple one, release the other, grapple again. The station arm has a shoulder, but that shoulder looks exactly like the wrist. In other words, at one end is exactly like the other, and both are able to do roll, pitch, and yaw. That makes it so that the arm can basically go in a big 360. The elbow, unlike my elbow, can actually go all the way, flip through the straight, and come back on the other side. Now, this robotic workstation uses a lot of monitors because there are not windows that you can do your robotics out of. And we also use computers. Some of them are used for our procedures, some are used for additional views, and some are used for a computer program that is basically like a virtual reality machine of what the space station looks like, so we can use it as a situational awareness. Well, from here, you have your hand controller, which again can do pitch, roll, and yaw. And you have your translational hand controller, which can go out and in, side to side, and up and down. There's different modes like we talked about. You can fly it manually. You can fly the station arm in operator commanded modes that are computer programmed. You can fly single joints. So many of the same things, but you do all of that from right here on the computer other than pushing buttons like we did before. A lot of our routing of cameras can be done on the ground, but you can also route cameras from right here and from right here. This is primary, and that would be our backup place. Again, we have ways to safe the arm with brakes, and we have ways to select different joints. So again, you're using switches over here. It's been an absolute pleasure talking to you today about robotic arms that are used here on the International Space Station. For me and for all of my colleagues to fly, we had to take a lot of math classes, a lot of science, engineering, and I hope that if you want to fly in space or whatever you want to do, that you work hard, pursue your passions, and remember that in school is really important to study math, science, and technology. Have some fun at our website at nasa.gov. Look in the education section under robotics, and I think you'll just have a joy when you are doing robotics. Take care.